Hello, everyone. We're coming to the last presentation of this first day of our TaiyangNews 500W Plus conference. And it's the first presentation where not a pure Chinese company is producing. We're happy to have now also Maxeon Solar present and have their Director of Product Management, Joshua Moore, being the speaker. A few words about Josh. Good morning, Josh. It's early, I believe.
Good morning.
Good morning. We're happy to have Josh Moore with us, who is in charge of managing the industry-leading Sunpower, Maxeon, and performance solar module product lines, ensuring effective implementation of strategies, roadmap, and vision for these products. In fact, Joshua isn't new to having such a role. He had similar portfolios at Cogenera. Some of you might know that, which had invented a single shingled cell solar technology, and that was taken over by Sunpower and is now, I believe, the heart of Maxeon's product portfolio. He worked at Stion's CIGS thin film solar product portfolio and even handled Ammonix's concentrated PV products. So a very broad range to almost everything solar has to offer. We are very glad to have Josh with us today, and we are also very glad to have Maxeon Solar introduce publicly for the first time its new technology after their capital event at our TaiyangNews conference here. Josh, the floor is yours.
Thank you very much. Yeah, I'm very excited to be here. This is a great day for Maxeon, and I'm excited to introduce the 5th generation of our Performance Series modules, as well as introduce Maxeon. For a lot of you, this is the first time hearing directly from Maxeon. And so I'll explain what that is. Maxeon is a new company that's spinning out later this year. It's the R&D, manufacturing, and global sales and marketing portion of Sunpower Corporation. So we're really excited about this new company. We have R&D spread across the world. We have 2.75 gigawatts of manufacturing capacity today that will be scaling up quite rapidly in the next few years. So we're a truly global company. We have a partner network of over 1,000 partners that install our products around the world. The corporation will be called Maxeon Solar Technologies, but we'll still be marketing our products under the Sunpower brand outside of the US and Canada. So the product names won't be changing, the brands won't be changing. So our customers will still get the great Maxeon products and Performance Series products from the Sunpower brand that they've come to know and love. This new company really has some great strategic partners. One of which is Total, which has been a longtime partner of Sunpower, a longtime investor in Sunpower. Total brings great downstream experience to this partnership. The other is TZS. TZS is one of the world's leading global wafer suppliers. And TZS brings great operational expertise to the manufacturing side, as well as capital to help us scale up our new technology. We've been a longtime partner with TZS through our joint venture called HSPV. And HSPV makes the P-Series modules that I'm proud to introduce to you today. The P-Series modules represent one half of our very successful product portfolio. The other half is the Maxeon IBC products. And they claim the top spot in efficiency, degradation rate, durability, and reliability, and are really the ideal products suited for space-constrained DG applications. Our P-Series technology enables us to take commodity solar cells and turn them into extraordinary modules, reaching higher efficiencies and more reliability and better looking modules that are ideal for the mainstream market. We've been making these panels for about 5 years. As Michael mentioned, Sunpower acquired Cogenera back in 2015, and we really started to scale pretty quickly since then. We've already delivered over 3 gigawatts of the Shingled technology to more than 60 countries around the world. So we're really happy about this new 5th generation that's coming out right now. As our esteemed colleague mentioned earlier, Charlie Gay, that shingling's been around for a very long time. However, Sunpower and Maxeon are really the pioneers in commercializing this technology. We believe we've spent more time and effort developing this technology and have created a great patent portfolio and a robust knowledge base about how to make the best shingled cell modules in the world. And I'll show you how those are a little bit different than some other shingled technologies. The P-Series is really a bundle of technologies. We take a normal cell, we cut it into 6 pieces, and we connect it with an aerospace-grade conductive adhesive. This creates many connection points between the cells, and those connection points are stronger than normal connection points. As well as we encapsulate it in our proprietary encapsulation that minimizes degradation from moisture ingress. Conventional modules are susceptible to cracking and thus power loss when they see the stresses of thermal cycling in the field. As you can see from the test results on the right-hand side, when we subject the P-Series modules to thermal cycling, there's almost no power loss, even after 800 temperature cycles. Conventional cells tend to lose 5–10% or more. And this is proven through our own internal evaluation as well as from DNVGL and PVL. I really wish we could all be in the same room right now, bumping elbows, seeing each other's faces, and more importantly, so I could show you in person this amazing technology and the flexibility and durability of it. But we'll have to leave that to my colleague on the screen here, who's showing how we can bend this long string of cells. We call this a hypercell. It's full of energy and flexibility. As I mentioned, it's a lot of small pieces of cells that are connected together through a very durable connection point created by a conductive adhesive. It allows it to flex and bend like no other string of cells. And that flexibility leads to long-term reliability and durability for our customers. Another way to demonstrate this is through a 4-point bend test. So here we subject our P-Series hypercell and a standard front contact mono-PERC cell connected by ribbons to a 4-point bend test of almost 400 newtons. You can see there's no power loss shown in the EL images on the performance series, but several spots where the conventional panel cracks and we see dark spots resulting in power loss. So as I mentioned, the P-Series is connected through many more connection points and more robust connection points than a conventional module. Cell cracks, shading, soiling, all of these increase stress on the panel, which can lead to encapsulant browning and backsheet embrittlement, even diode failure. We've designed our module to be cooler, and cooler means safer. Safer means longer lasting. What you can see here is that when we put a small amount of shade on a performance series panel, the module doesn't heat up very much. The unique circuitry allows the current to flow around that shade, not creating a spot where the module can get really hot. On a conventional half-cell mono-PERC design, even designs from several different companies, we see that the modules get quite hot and into what we call the reliability risk zone, where you can see backsheet and encapsulant damage and ultimately power loss from that module. Not all shingling is created equal. We've even tested other shingling and tiling ribbon designs through the same type of test, and they don't perform like P-Series. As I mentioned, we're the pioneers in this. We spent more time developing this shingling technology and more R&D investment than anybody else. And what that results in is a more reliable design. So we're, I think, several years, if not many technology generations ahead of where most people are on their shingling technologies. That results in a more reliable module. But you don't have to take my word for it. We've subjected our modules to a variety of external testing, one of which would be the PVL DNVGL module reliability scorecard testing. Our first generation P17 modules was a top performer, as was our more recent P19 module. And we have other generations of the P-Series technology going through this testing right now, and we expect similar results. So it's a great technology, and we want to make sure we protect it. So we have a lot of patents in many jurisdictions, many that have been granted and many that are still pending. We have patents on not only the design, but the manufacturing process to make the modules. We believe this is a very strong patent portfolio, and that we've patented the best ways and most cost-effective and reliable ways to do shingling. We've got the great platform, and now we're ready to scale it up. We started with a proof of concept, which is our 400 megawatt facility in Mexico, making the P-Series P17 modules. For the last several years, we've been scaling up and demonstrating high volume capacity with our P19 and P3 through our joint venture with HSPV. And now we're ready to grow even faster, up to 8 gigawatts by next year. We've got the right platform to do that. We're working with TZS, who's the world's leading supplier of the G12 wafers. So TZS will supply the wafers, and HSPV will convert those into the world's best performing shingled cell modules. What we're launching now is the 5 hypercell version, which is reaching 540 to 545 watts, and we'll soon be introducing the 6 hypercell version that reaches up to 625 watts per module, one of the most powerful modules in the world. We continue to evolve this product portfolio, and as module sizes change, we like to take pride in being one of the first to lead in this innovation. For a long time, 72 cell modules were almost all the same size. And in 2015, we introduced the P17, which is a little bit longer and more powerful than a typical 72 cell module. And we're continuing on that innovation by launching the P3 UPP, which is a little bit wider and larger than a standard module. And then today with our P5 UPP, which will reach, as I mentioned, 545 and up to 625 watts. So we're really proud of these 2 new technologies. Something else that's unique about these modules, it's our first time launching a bifacial version of the P-Series module. And one of the great features of the shingling technology is a parallel circuitry that minimizes loss from shading. This also enables better and more consistent bifacial power generation on the backside. Also unique to this module is that it's a framed dual glass construction. It's our first dual glass P-Series module. We believe this will lead to extended reliability for both the 545 watt and 625 watt versions that will reach over 21% module efficiency. We work closely with our downstream balance of system partners, both on the inverter side and the mounting system side, to make sure that we're designing modules that are optimal for their current systems, as well as making sure that they're designing future systems that are optimal for our future modules. It's been a lot of LCOE examples today, and everyone likes to say that their module is a little bit better than the next one in terms of LCOE. Certainly we've done our calculations as well and shown that the energy yield advantage from our module, from this better performance because of the circuitry of a P-Series, having less losses from shade, soiling, as well as the bifacial gain, that energy yield leads to better LCOE and more savings up front. As well as the larger, higher efficiency P-Series module means less labor cost, less balance of system cost, and therefore more value to the end customer, more valuable for our modules. But all these LCOE calculations are just Excel magic unless you can prove the reliability, improve the energy generation. And that's what we've done by subjecting our modules to third-party testing, showing that they're really going to last the 25 and 30 years that we expect them to, and will meet the performance requirements that are needed. Maxeon's got a deep global experience in power plant, whether it be the first solar project, Various Solar One that we did back when 10 megawatts was considered a large power plant module or power plant application, to the Solar Star project in 2015, which is the largest project in the US at the time. It's about 750 megawatts. To more recently, we've developed a 350 megawatt project in Australia using our P-Series modules. So we have experience doing the full range of development, EPC work, but of course our core technology, the P-Series modules, is ideally suited for power plant applications. So we know what it takes to develop a good project, and we can work closely with our partners. Our goal is to offer the best module that's suited for maximizing the value of the EPC, the developer, and the IPP. So we look forward to working with our customers on developing even more P-Series as we scale up to 8 gigawatts. We're really excited about this new P-Series 5th generation product, as well as the introduction of Maxeon solar technologies We look forward to working with you in the future. Thank you.
Thanks, Josh. Very impressive. A few questions first from my side, and then we'll see what the audience is asking for. So you mentioned and highlighted your partnership with Zhongguan, with the TZS. Can you elaborate a little bit on that? So how that looks like? Because obviously they are a wafer manufacturer, and they also have to, since they are the only one at the moment offering 210 millimeter wafers, they have to offer that product also to others. Can you just give us a bit more background on this?
Yeah, it's a great partnership. So as you mentioned, TZS is leading the industry and offering this 210 millimeter wafer. So TZS is a great partner for us in terms of scaling up our joint venture HSPV that makes the P-Series technology. The TZS supplies the wafers to cell vendors that then convert those wafers into cells. And then HSPV converts those cells into the P5 modules. So we've got a nice kind of end-to-end ecosystem there where we're able to work closely with TZS, thinking about long-term technology roadmaps, making sure that our module roadmap is aligned with the wafer roadmap. And the shingling technology offers some unique advantages in terms of using these larger wafers. We can cut the cells, cut the wafer into whatever size we want, shingle them together, and then create a module that's optimally designed for today's power plant tracking systems. So it's a nice marriage between going larger wafers and using shingling to create the ideal panel technology with the right current and voltage. As well as TZS goes to thinner and thinner wafers, the shingling technology with the robust connection and flexibility will enable the industry to move to thinner and thinner wafers. So that's the partnership from a technology perspective. And then from a scale and manufacturing perspective, TZS has invested in Maxeon and is going to help Maxeon scale up both the P-Series technology as well as the Maxeon IBC technology. So their great operational expertise and access to capital is going to help us scale to really a world-class company.
Okay, cool. Okay, interesting. So you also, what about, because I think you're using conductive adhesives, it brings this flexibility, but there's one application which is at the moment also becoming very attractive, as we're seeing also land constraints, at least in denser populated areas, so floating solar. So how would that work to use these modules in these humid environments?
Yeah, the floating applications present a new challenge, more humid, more movement. So this is really a great place for P-Series. We've already installed P-Series in a number of floating applications around the world, but the reliability and durability I talked about, whether it comes from the flexibility of the cell connection or the great encapsulant we use to prevent from moisture ingress, all those make P-Series ideally suited to be mounted in a floating application. So we're excited about the growth of that application and the use of P-Series there.
Okay, there's also a question also related to climate, and I think that probably fits very well. So you've shown also that you've installed systems around the world. So how is the adhesive affected in really hot climate in desert areas?
Yeah, so that's a great question. And actually the history of the technology shed some light there. So as we mentioned at the beginning, the technology came out of Cogenra. Cogenra was making concentration solar systems. So we were concentrating light on solar cells. And what we needed then is something that's really efficient and can withstand high temperature and high temperature swings. And that's when we started using the conductive adhesive. So we proved it at much harsher applications than what we would ever use now on a single concentration system. So we've proven it at 25x concentration, which, as you can imagine, if you've got 25 times the sun on the conductive adhesive. It's getting a lot hotter than it would under one sun. The conductive adhesive, as well as the rest of the module design, is really well suited to high radiance, high temperature climates. And we've shown a lower temperature coefficient than a standard module design, which helps energy yield at those high temperature locations, as well as the extensive chamber testing we've done to show that the conductive adhesive holds up better than a standard solder joint in those high temperature applications. It's really the temperature swings that are causing the degradation in most modules. And so that conductive adhesive can withstand the high heat, but then also cooling quickly from a high heat to a colder temperature. It's ideally suited for that type of application.
I think there's also one question regarding weight. Can you reveal the weight of these products? So how much they weigh?
Yeah, we can certainly. I think we'll be releasing the data sheet on our website very shortly. That'll have have all the module weights, but it's a pretty thin dual glass module, so well within the normal weight requirements of a commercial power plant module.
You've also shown that that it's the first time that the modules are bifacial. So can you just tell us a little bit more about that step, why you went that, and your experience and testing results that you had?
Yeah, so Sunpower's been testing bifacial modules for quite a long time. Even looked at bifacial for our IBC technology. We've had P-series bifacial modules in our test beds for several years and have been testing and monitoring those products and their performance. We felt like now it was the right time. The industry's moved there from a cell development perspective. We also think it provides the right economics in most power plant applications to move toward bifacial. So this was the right time in the evolution of our product roadmap to introduce a bifacial module. The technology's ready and the market's ready for it as well.
Okay. There's one question. Why does shingled modules perform better than conventional modules under shading?
Yeah, it has to do with a few things. The parallel circuit of the module. So each of those columns of cells that I showed that we called a hypercell, those operate independently. So if we were to shade part of one column, the other 5 columns operate independently, still producing power. As well as the way we have the module divided into sections. When the module is in portrait and you shade the leading edge, we only lose about 1/3 of the power output, whereas in a conventional module, if you shade the bottom edge of the module in a standard full cell, you would lose pretty much the whole module. All 3 diodes would kick on, whereas in a half cell, probably the bottom half of the module would shut off. Only about the bottom 1/3 of a P-series module would shut off. We have the module divided into thirds vertically with our diode configuration. And then in landscape, as you shade the leading edge, you only affect that leading hypercell, and the remaining hypercells above it operate at full power and full voltage, which are both important. So it's operating at full voltage, staying within the optimal window of the inverter and keeping in that whole string at the optimal voltage range. The other aspect would be, because we have these many connection points between each cell, a very small portion of a cell is shaded, the current can flow around that blocked area pretty easily without causing much power loss. So there's a lot of degrees of flexibility for the current to flow through the module and around portions of shade or soil.
Okay. You also mentioned that you have a very strong patent portfolio. Nevertheless, someone mentioned that there are some Chinese products being shown actually that are based on shingled technology. Can you comment on that? So how are you seeing that?
Yeah, I think it's best for me to let our legal team handle all the IP discussions, but we're certainly monitoring our competitors' technology and keeping track of areas where they may be violating our patents.
Okay, okay. There's also a question regarding standards, because of course you are a leader in this field, and the question is, are you happy about the IEC standards? Are they sufficient actually to reflect also your unique technology?
Certainly, I think for the industry, it'd be nice to see maybe a more stringent hotspot test. You know, they showed our module can stay much cooler and thus safer for a power plant system or a commercial roof system. And I think that safety is important. So I think a more stringent hotspot testing could be interesting. I think the IEC tests are a nice base benchmark, but the industry has shown that going beyond that type of testing to several times the IEC standard is typically needed to prove the long-term reliability of a product. And I think that's why tests like the PVEL scorecard have evolved and become so popular.
Okay. And there's one interesting technical question. So you showed that the string is nice and flexible, and what happens actually, and also maybe then in comparison to a conventional module, if a cell breaks?
Yeah, so if there's a crack in one of the cells that are in a P-series configuration, typically we experience less power loss and less risk of a hotspot for a couple reasons. One, the cell is smaller. It's 1/6 the size of a standard cell. And so the current of the cell is lower. So if there's any sort of resistance, the resistance is at 1/6 of the standard cell. Also, because the cell is smaller, if a crack gets initiated, it typically will end at the end of the cell. And so it will only travel 1/6 the length of a normal crack. So the power loss would be smaller. And then also, instead of having just 3, 4, maybe 5 connection points between cells, we have many, many connection points along the edge that are created by the connective adhesive. So there's many pathways for the current to flow around the crack. So typically less power loss associated with a crack in a P-series design.
Okay. You also said and showed that you're really flexible in how you can kind of configure the modules, because it's very small and you can adapt it to the different needs. But if you look a little bit into the future, so we've seen recently a very rapid growth in power ratings. Is this the way to go, or but we've also heard from several presenters today, of course, that there are limits, especially when it comes to logistics. So what are you seeing when you look at your portfolio?
Yeah, we're excited about the 545 watt size P-series that we're introducing. We think the industry is ready for that in terms of logistics, shipping, tracker design, inverter design. And then I think there's a nice ebb and flow in partnership with the balance of system providers, where module vendors are able to start to show larger modules like we have with our 625 watt module. And when we partner closely with the tracker system designers to make sure their next generation of trackers are ideally suited for that particular application. So I think we'll see a constant push for larger and larger. I'm excited about the innovation that'll be coming several years down the road. I think that will lead to even lower cost power plant designs. It certainly seems like bigger is leading to cost reductions at the moment. I'm sure we'll hit we'll hit a maximum at some point, but I don't think we're there yet.
Okay. Okay. I think there are also a couple of questions regarding the data sheets, but I think that these guys should wait until it's out.
We'll have it out very shortly.
Yeah, maybe there's one thing talking about what about N-type cells? How is it your shingling technology is suitable with N-type technology? Yeah,
so ironically, the one technology that shingling is not suitable for would be back contact, which is our Maxeon interdigitated back contact solar cells. We couldn't do shingling there. We need a front contact to do the shingling. So it's a nice separation between the product portfolios. But we've worked with N-type TOPCon and N-type heterojunction in the past and have shown that Shingled works very well with those technologies. We're constantly monitoring the evolution of the technology and the cost structure of those technologies, as well as the long-term reliability. And once those technologies reach the right proof points, I could see us introducing an N-type version of P-series at some point in the future.
Okay, I think that's perfect. So no more questions from my side.
Excellent. Thank you for your time. Appreciate it.
Thanks, Josh. That was a great presentation, and I think that was a nice, nice statement at the end of this first day.